It wasn't right. We have Zoidberg here to help us out. Thank you,
Okay.
Zoidberg. Thank you. Oh, technical errors? Why not Zoidberg?
Yeah, why not Zoidberg? Okay, so
Oh, so hang on. We should probably start all over since everything got botched repeatedly.
I agree.
Hi, everybody, and welcome back to the Unreal Engine training stream. I'm your host, Alexander Pascal, and joining me today, Sam Deiter.
Hey, everybody.
We're going to be talking about baking materials to textures for optimizing your game. So now that we've done that.
So yeah, so I was working on something for Gear VR, doing some optimization stuff, and Alex came to us and was like, look, we need somebody for a live stream. And I'm like, hey, I'm kind of cannibalizing some tools and using them in some interesting ways. And that's kind of how today's talk came about.
I asked, he had something.
Some of the stuff that I am talking about today did come, some of that inspiration I pulled from the great and influential Ryan Brooks. Some of the last example I'm going to show you guys today is the most complex. So it goes super simple, intermediate, and then kind of complex. And that one builds upon Ryan's blueprint and render target stuff, which you can find by coming here to going to view options, show engine content, and if we click on engine content, we go down to art tools, render to texture right here. You can have all the blueprints. Oh, yeah.
Main screen turn on. Wait, go back.
There you go. Okay, so let me just go ahead and do this again really quick. So to go ahead and see the tools that Ryan built, you can come here to view options. You go show engine content, and we're going to scroll down here to engine content will be collapsed for you. So engine content, art tools, and down here into blueprints. And these are the 3 blueprints that you'll use. And there is some documentation on the web as well.
Oh, yeah. Is that those links that you gave me?
Yeah, I got actually one of them here. Hold on. Let me pop this in the browser really quick, and I'll just pull over the... So the render to texture blueprint tool sets. Some of this stuff is way easier to do with render targets and blueprints now, but this is still very, very useful. And like I said, I used a lot of this as some inspiration on ways to bake some things out when I ran into some problems with stuff not baking correctly. The other thing that I wanted to share with you, everybody, today is this right here. Which is the NVIDIA texture tools for Photoshop. What this allows you to do is it allows you to create normal maps inside Photoshop. And we're going to use this when we export one of the normal maps out. We're going to need to recompress it and actually renormalize it so that when we import it back into Unreal, it shows up like a proper normal map. And finally, I actually uploaded this entire project to Box.
Yep.
And so if we go to this link right here, you can download this project. It uses 416. It's just the realistic rendering example.
No,
and it's just got a couple of
linking these into chat,
Okay.
and we'll have links to these in in the description of the YouTube archive. But just as a note, sometimes Box gets overwhelmed, so I might also like archive it somewhere else and post a link to that archive.
Okay.
So if you are all watching this live and you all rush in because I just posted those links, note you might accidentally step on each other's toes, and Box won't let you all grab it at once.
Okay.
So just try again in a little bit.
Good to know.
Yes.
So let's go ahead, and now that we got the shout-outs out of the way and some of the tools that we've been using, let's go ahead and get started with creating textures from material. So overall, why would we want to do this? Well, the main reason we'd want to do something like this is, let's look at this desk lamp. And we see that this desk lamp has 2 materials on it. It has something for, and I'm in unlit here, that's why you're not seeing any reflections. But basically, there's a metallic material for the base here, and then there's another material for the shade. Now, 2 materials, that's not so bad, but if you had, 10 of these lamps in the scene, each one of those having 2 material IDs, that's going to add up to be a lot of rendering that's required just to draw this stuff to the screen. Now, what would be better, obviously, is to have one mesh with one texture with one material. So it just makes one draw call for that object, because it's super cheap and you're getting it at a fixed cost because you have effectively taken any complex shader math that you've done and you've cast it aside, you've baked it into that texture, and now it's all there for you to use. So a couple caveats before we move a little bit further. If you're doing something like crazy world position offset, or you're doing like animation or stuff like that, it's not really going to work.
Anything that's like dynamic in the material that makes it move around.
Yeah. This will be really good for, say you make a really complex weapon, and when you're modeling, it's a lot easier to just assign a texture to a bunch of polygon groups, and maybe you planar map that, and it's not in the 0 to 1 space, and it's just a little easier to build, depending on your workflow. Some people go straight up UVs and they just flatten everything. Some people like to just dump a material on a poly, but what this method allows you to do is no matter which way you do that, using this method, you can actually just bake everything out to a texture and you will get everything back in. Now you're going to get a few precision errors because especially if you're using like a masking style system where you have a mask and then you have a texture that you're repeatedly tiled, you're just going to have better fidelity with that. But if you're doing a mobile project or a console project, or you're trying to bake something down maybe for your LODs, you're going to do a different material for your LODs or something like that, or you're okay with a little bit of a drop in fidelity, this method will save you tons of time doing stuff because you're not going to have to do it in Max or Maya and Photoshop. You can do everything inside Unreal with everything that I'm showing you. And this is the cool part, is that it's all done in Engine. So let's go ahead and get started. The first one we're going to talk about is the Merge Actor tool. Now, normally with the Merge Actor tool, you grab a bunch of different meshes, you merge them all together, and what that's going to do is it's going to take every single mesh, it's going to lay out its UVs in the 0 to 1 UV space, and then it's basically going to make a texture atlas. So it's going to put the base color, roughness, and normal for one object, and then the second object, third object, so on and so forth. But one of the cool things you can do is you can actually use the Merge Actor tool to just merge this object. For example, we're going to merge these two material IDs. So these two draw calls, we're going to merge them down into one draw call. So let's go ahead and take a look at how we're going to do that. So to access this tool, we come up here to Window, Developer Tools, and Merge Actors. So here's the Merge Actor tool. First thing we're going to do here is we're going to set to use a specific LOD level. And what that's going to do is that's going to allow us to now adjust our material settings. Because if we don't do this, all it's basically going to do is just merge. It's going to merge everything together, but it's going to give you this monolithic static mesh of like 20 material IDs. And so one material ID for how many things that you want.
Yeah, that seems pretty bad practice.
Yeah,
You don't
it's
want
not,
that one.
I mean, I don't know. Maybe you want it if you're exporting a level or something. Who knows? There might be a way that you want to use that. But for our purposes, we're going to want to go ahead and kick this down to specific LOD level. Right now, we're just going to capture it at LOD 0 to make sure we get the highest version of the mesh. Then we're going to go Merge Materials. I'm going to kick my Merge Material settings down. Right here, our texture size, 1024 by 1024. This is going to be the size of our ending atlas, so how big it is. I'm going to keep it at 1024 by 1024 for now, because the larger I make it, the longer it's going to take to compile, and we're just going to have to sit here because there's nothing I can do with the editor while this is baking out. Actually,
and since we're live, that might take a second.
Actually, probably going to kick that down to 256 by 256 just to be on the safe side a little bit. And I actually, as a true live show, cooking show style, I actually have this pre-made in a high-res version.
You could have pulled like the full turkey out of the oven, like, haha, and this is the complete turkey.
So what I'm doing now is normal maps, a metallic map, and a roughness map. So basically, I am telling this tool which maps I want it to generate once I click the Merge Actors button. So I know that I want a normal map, I know I want a metallic map, and I know I want a roughness map. I'm not going to use a specular because I want to create as few textures as possible because I want this to be as small as possible. I'm going to leave the blend mode here at opaque. I'm going to leave use vertex data for baking materials enabled. That's just basically if you're using vertex colors for something, it's going to transfer it over. Finally, this use texture bending, I'm not going to use this, but this will basically scale stuff down according to how relative it is or how important it is. With this feature, I usually do something like I'll do 256 by 256. I'll turn it on. I'll see if it gives me what I want. And I'll turn it off. I'll bake it again. It's just kind of one of those things that you have to kind of test with a little bit to see if it's going to give you the settings that you want.
It's more of an art than a science, I see.
A little bit. So finally, we're going to click.
Wait. Darn. I was going to say, actually, Clint, can you drop us from the thing here? Because technically, we're covering up that button. No. Show just the main screen, I meant. Yeah, full screen main screen.
There we go.
Yeah, because the button was underneath our picture.
So now what we're going to do is we have everything set. I'm going to click on Merge Actors. Now I'm going to have to give this a location. So I'm just going to come up here, a new folder, and I'm just going to click Save. And my new folder, there we go. And so this is going to go through. And again, it went relatively quickly because it's only 256 by 256. But if I open this guy up, you see he's only one material. Let me go ahead and I will pull him into the level. And let me just zero out his transform really quick. 0. And let's just hold down shift and we'll move over. So we move our camera.
Oh, it was really far away. I thought it was scaled down a lot.
No, it's just, there's nothing in there.
I see.
But, so now we can see that I have, so if I click on this one, I have 2 materials. I click on this guy, I just have 1 material. So this is really, really, really powerful tool to use. And you're not actually doing anything different with the tool other than instead of selecting maybe 15 or 16 meshes at once and doing this, I'm just selecting 1. So this is really good if you're at that point in your game where you're trying to optimize everything that you can in order to hit your target frame rate, and you see a bunch of meshes that have 2 materials, 3 materials on them. This is a great way to optimize all of that stuff very, very quickly, and then non-destructively as well, because this mesh right here that it created is actually a copy of the other mesh that is actually a copy of this mesh right here. So I'm not actually losing any data. I'm just generating another mesh. Now, while that does add another mesh to your project, if you happen to screw it up or you want to revert or something like that, you can always go backwards. And that's awesome because, again, that's non-destructive to your workflow. It's non-destructive to your pipeline, which is a good thing. So the next one that I want to talk to you guys about after the Merge Actor tool is using blueprints and render targets. So in this guy here, let me go ahead and we're going to go to blueprints and render targets and double click on this level, and we're not going to save anything. So what I'm going to do is basically see this coffee table right here, and if I come to his main material, and let me just open this guy up and zoom out, you can see right here we're using, so this mask material, we're using this texture, 2, 3, 4, 5. So we're using, I guess I could have done that by turning on the stats and showing them down here in the window. Actually using 8 out of our 16 available texture samplers. So on mobile, this would be a very expensive shader to use, right? We wouldn't necessarily be able to do this. And if we look at this, what this is really doing is it's using a lot of masking, based off of this texture right here, which I think this guy's like 2K or something like that, the size of this mask right here. And but if we look at the coffee table, let me pull him into the scene and just hit F to focus in on him. I mean, there's not a lot going on with this coffee table, right? It's got a super, super, super high fidelity wood on it. And that's because if we look back over here in the material, we're actually scaling the UVs to give us that super awesome fidelity. But what if we could take this final material that we have here and just, again, bake all of this down to a material so that we have all of this stuff at a fixed cost. And we can do that using a blueprint and a render target. So what we would do, first I'm going to delete this guy. I'm just going to right click. I'm going to create a blueprint class based off of actor. And we'll just call this BP underscore render target. Okay, and the next thing I need to do is right click in here, go to materials and textures, and we are going to create a render target. We'll just call this RT texture Baker. I'm having problems coming up with names on the fly for some reason. So, and this guy's popped over here.
I just called them all Bill, John, just to be really confusing with my naming conventions.
So the first thing that we're going to do is we're going to come over here and we're going to actually delete everything from our event graph. And we're going to come here, we're going to make a custom event. And we're going to call our custom event bake. And then off of bake, we're going to do a draw material to render target. Okay. And then what we're going to do is we're going to pull off this guy and we're going to promote to a variable. And we're going to pull off this guy and we will promote to a variable as well. Let's compile, and then we'll come down here and we'll just rename these really quick. We'll call this one render target. We'll call this one material to render. Okay, move these guys down so we can see what they look like. Press compile. Now over in our construction script, what we're going to do is we're actually going to want to call our bake function here. And what this is going to do is basically when we move this guy around, and the last thing I want to do, what this is going to do, sorry, I got jumping ahead of myself here in my head. What this is going to do is each time we move this thing around in the level, it's going to update the render target so that we can then right click on the material, the render target, and save that as a static texture. And I'll show you that in just a second. But first I want to come down here and I want to make these guys public so that I can go ahead and actually change them in the level, so I don't have to keep coming back to the blueprint, supplying the material that I want to bake, and doing all that, because the workflow can be a little cumbersome.
Wait, should it say mater to render or material to render?
Yeah, material to
That's
render.
all. I just figured like, later you're going to be typing that in like, wait, that's not right.
Material
Right.
to render.
Typos are the funnest kind of syntax error.
No
aren't they?
global spelling check. So what I'm going to do is I'm going to drop this guy in the world, and I'm just going to zero him out. And I'll hit F to focus in on it. And I actually have my other one there, so let me delete that really quick. So first, I'm going to take my render target. I'm going to drop my render target up here. Now, for our coffee table, if we look at this guy, and I go ahead and notice he has this very dark, like dark red stain on the coffee table. But if we look at the actual coffee table, and let me pull this back over on the screen, you notice it's not as dark. Well, that's because inside the material instance right here, they've set a bunch of different things up. Now, this is something kind of cool that I found out you can do, and I didn't know you could do this. What we can do here is I can actually grab this material to render. I can pull this material instance on it, and then you'll see why this is cool in a second. So before, I didn't realize material instances could go on there because I'm calling a material. That's what I used. I used a material node inside of the blueprint. That's why I was a little confused when this started to work, but it kind of makes sense. So what I'm going to do now is I'm going to come in here, and in order for this to work, I have to turn the material that I want to render to the material target, I have to turn it unlit, and then I have to pass each one of the inputs to the emissive channel. So what I can do is I'm going to come here and I'm going to go, under my shading model, and we're going to click on unlit. I'm just going to click apply really quick. I'm going to come all the way up here to this input, which was my base color. And I'm going to right click on him, and we're going to go to the emissive color, and I'm going to apply that guy. So now what should happen is when I move this, you can see my texture baker updated. So I'm going to right click, and let's just double check really quick how big it is. So 256 by 256. Let's go, we'll bump it up to 512 by 512 to give us a little bit of extra fidelity. But again, I don't want to go ridiculously high because I don't want any crashes to take place. So let's go ahead and move this guy one more time. So now it updated, so I'm going to right click, I'm going to create a static texture. And if I come over here and we disable the alpha, you can see now I have my base color. So that's all the inputs for my base color, right? So let's go back to my coffee table, and we will go to what's going into my metallic. So we'll right click on this, we'll connect to emissive color. I'll click apply again. Let me just move this out of the way, drag him over, right click, create static texture, and I will bring this back on screen for you guys. Whoop, there we go, there's my metallic mask.
And you just switch it over to alpha, and now you can see it.
So the last, and then we will do, let's see here, where's my, so we'll connect this over to emissive color. That's my roughness. And we'll close this guy, move this over, and right click, create static texture. So
and the little jostle's an important thing to do, right?
yeah, the jostle is basically that's updating, that's changing the data that's inside the render target without me actually having to play the game or doing anything like that. So
cool.
Again, you can see there's my roughness, and then finally the coffee table is a little bit of an interesting one. There's actually no information inside of the normal map. The normal map isn't being augmented, say, by a detail normal or by some other parameter. So for this one, you actually wouldn't need to render out another normal map. But just to show you guys that you can actually get everything out of here, we're going to go ahead and click on this. So we put the normal map into the emissive. I jostle this thing around, right click, create static texture. And if I bring this back over and I click alpha channel, you can see I have my alpha or my normal map here. Now, one thing I want to bring up about the normal maps, all of these textures, I actually should have converted all of them, and I messed one thing up here. I forgot to turn on my my render target. Where's he at? This guy right here. Whoops. I forgot to enable, HDR is enabled. That is one thing that's very important because HDR is going to give you a little bit more fidelity than the standard texture output, like outputting to PNG or something. But so if I come here and I export this guy out, so we go Asset Actions, Export, and Hopefully it will do it. There we go. Whew, that was a close one. I was a little scared. We're going to go ahead and save. The reason that I'm doing this, what I'm going to do is I'm going to take this photo or take this texture into Photoshop, convert it to 8-bit, and then bring it back in. The reason that I'm doing this is if I try to convert this texture that it output, the normals either are too steep or they're not steep enough. I don't know what is going on internally inside of Unreal, but just doing this little bit of an extra step will make it so that all these textures are the proper format, but they'll also work with the streaming system and all that other stuff. So you're not losing anything, although it introduces a little bit more work. What I'm about to show you is super simple to do. So now that we've exported it, let's go ahead and pull up Photoshop. So we'll do a file, we'll do an open, we're gonna go to our desktop, and let's see, there's our texture. So you can see I'm opening up an HDR texture. So what I'm going to do here first, I'm just going to go to image mode. I'm going to change this to 8-bit. And right here for our method, I'm just going to go exposure and gamma, and I'm going to hit OK. And you see I have the exact same color space that I had before. Okay, so I'm not, my texture didn't change, the information didn't change. Now if I hit Control-Shift-S on the keyboard, you can see I can say this is a PNG or a TGA. And then when I re-import this, it'll come back in. Now, let me go ahead and jump into my finished folder here. And let me actually do one other thing, sorry. Let me pull the coffee table back out, and we will 0, 0, 0. So come here to the coffee table, and I'll go to my finish, because you can see my finished one here, I have them at 2048 by 2048. So you can see they're very, very high res. And if I go ahead and pull this material on here, and let that guy compile really quick, and let me just pull another copy over, and we will go back up to this guy. We'll pull him back over the screen. So what we're going to do now is we're going to come to the emissive, we're going to disconnect it, and then we're going to come here and we're going to say default lit and click apply. And voila, you can see basically this is our baked one, this is our unbaked one, and you can see there's almost no difference in between the two of them. And again, I'm looking at them unlit, but I do this anyway just to show you guys that there's very, very, very little difference between the two of them. In fact, like look at the fidelity right here. Okay, and this is our baked one, and we can check out the same fidelity over there. It's almost identical.
Yeah.
So again, super duper powerful way to optimize stuff. Even though you have to introduce a little bit of Photoshop, this method will still allow you to optimize your level and have full control over the optimization. So it's on which of the ones that I use, the one that I'm about to show you now is the one that's based off of Ryan Brooks, and this is using a much more complicated blueprint. It's using the high-resolution screenshot tool to capture. But the reason I had to use this one was, in the realistic rendering example, we have a bunch of books on the bookshelf. Well, those books are colored by the position and the rotation of their world, of their placement in the world.
That's very true. If you give them physics and throw them all over, they start flashing different colors, I found out.
So little seizure-causing books.
Yes, basically.
So when I went to go bake them out, they were all turning black. And I'm like, well, how do I do this? How am I able to capture this? I can't rotate it because the rotation isn't taken into account in either of the methods that I just shared with you. Rotation doesn't matter. So this last method, what it's basically going to do is it is literally going to flatten the mesh's UVs, and then we are going to do a play in editor, and we are actually going to make our window 512 by 512. We will high-res screenshot times whatever multiplier we want. So times 2 would give us 1024 by 1024. Times 4 would give us 2048 by 2048, and so on. That will output to a folder, our saved folder, like we do with a screenshot, and then we'll be able to bring that information inside of Photoshop, convert it to 8-bit, and then import it into Unreal.
That is some interesting trickery.
Yes, and like I said, this is all thanks to Ryan. He mentioned something to me about flattening out meshes, and I was on the way home in my car. I have like an hour drive home, and I was, how can I do this? How can I do this? And I'm like, wait. If I rotate it and then I flatten it, it'll still retain the same color. And so that's kind of how I got there. So let's go ahead and look at that. Do we have a question so far?
Someone was wondering if the materials on both of those were actually, can you click on one and then click on the other? They have the same material on them.
Do they have the same material?
No wonder they look so similar.
Yeah. Hold on one second here.
Let's see here. Good catch, Lucas.
Thought they had the same one. Let's see here.
Oh.
So there's that one. Yeah, see, like I said, they're
Very similar, though. See, that's the,
yeah, that's the actual parent. So,
see.
all right, it definitely changed.
All right, cool.
Let's just double check. Just one more time, I'm paranoid now. I didn't want you guys to think that I'm selling you
No.
porky
Okay,
pies.
so they just look really that similar.
Yeah,
And they have
they-
like probably the beginning of the name is just so similar.
Yeah, so there we go. There's that one. And there's this one over here. So yeah, they do look very, very similar. So and there's almost no difference in this one. But that was a good catch. That was a good catch.
Incredible technique.
But I just want to make sure you guys know that there is no trickery in there. And you can download this project and check it out for yourselves as well.
Yeah,
So,
I'll put the link up again in the chat because we have some new people around.
so let's go ahead and open up the flattened example. So here's my book. And as you can see, like as I rotate it around, you see it's going to change color. So this one, what we've got here is I have this flattened pawn. So if I come here to my window and we're going to go to my world settings, actually, no, I'm going to do this another way. I'm going to take my pawn, which I should actually already have it in the world right here. And we're going to make sure that auto possess is set to player 0. Okay, so basically when I spawn into the world, I'm automatically going to possess this pawn because we are going to be taking a screenshot. And you can actually see this right here, what our pawn is right here. So this book's UVs are going to be unfolded and then mapped out into this little plane right here. And we're actually going to take a screenshot of this plane. And to do that, the first thing that we need to do is we need to come up here to our material. And let me go ahead and close this down and close this down. And I've included this, but basically there's this material function called unwrap UVs for render. Okay, and it's this material function right here. I just took it out and pasted it into my graph and added a little static switch so I could use it inside material functions if I wanted to or not. And what this is simply going to do is I can show you right here. Whoops, I need to add an actual one there. I am not firing on all cylinders today. I need to actually enable it. So let me find my book mesh really quick. So I'm going to select the book mesh in the content browser, and when we get back, there we go. So this is what this material function is doing. So basically it has taken my book and it has just flattened out the UVs and made it so that I can see everything on it, right? It's not ridiculously complicated. What I'm going to do next, though, is involves a little bit of trickery. So I'm going to go ahead and hit cancel, and I'm going to set this guy back to false because I don't always want him unwrapped. We're going to go ahead and close this. And on this guy, should have this material instance here. Yep, and I'm going to enable the flatten on my material instance. Okay, and this is the same material that comes from the actual book mesh itself. I just made a copy over here in the folder so that I wouldn't be affecting anything else. So here's our material, or here's our object that we want to capture. Let me go ahead and hit Control X really quick. Now, if I hit play right now, you're not seeing anything. See, I'm controlling it. What I really want is I want my viewport to look something kind of like this, where I have the book there, and then I can do something like, alt print screen or high res screenshot. But obviously there's a couple problems. Right now, look, it's offset, it's rotated a little bit to the left, and also it's not as big as the UV sheet itself. So no matter what I try to take right now, this is going to be offset and it's not going to match up. So how do we go about in doing that? Well, if I hit Control V and I put my player back in, let me go ahead and hit play. Now, if I hit F2 to bring it in unlit, you can see there is my entire book inside of a 512 by 512 window. So if I was to go high-res screenshot × 2, this is going to output me a base color, a roughness, a specular, a metallic, a world normal map, which I'll show you how to convert inside of Photoshop. it's basically going to take all of this stuff for me. But so how did I get that? How did I get from not being able to actually, from being able to control this window to having this window perfectly line up with everything? Well, that's inside of the blueprint. So first off, what I did is I right-clicked, I made a new blueprint class that's based off of pawn. And then inside the blueprint, I added a scene and I added a camera. And let me go over to my viewport really quick so you can see where they are. Where's my camera at? Come here, camera. Where are you? There we go. With my camera, I moved it up about 3,500 units in the air, and then I set its rotation to 90 and negative 90 so that it's basically facing down because I want to be able to capture what I'm looking at. The next thing I did is over here in the camera settings, we changed it to orthographic. We changed the ortho width, and we constrained the aspect ratio to 1. Again, a lot of this stuff, I was fumbling around with it, and then I looked into Ryan's render target blueprint, and I saw some of the stuff that was similar, so I started just kind of taking apart what he did at a very, very low level, and just got the simplest thing working, and then added a little bit more and a little bit more and a little bit more until I have what you guys see right now. So, you know, it wasn't just all of a sudden everything started just kind of coming together. It started with me figuring out how to get stuff to flatten. And then after that, okay, now that I've gotten to flatten, how do I capture this? So the next thing that you need to do is add another variable called sheet size. I set it to 1,000. You might be tempted to set this to like 1024 by 1024, you know, if you want to take a large scale, or 512 by 512. If you do that though, you end up cutting off a few pixels on the left and the right. So you want to make it slightly smaller than the dimension that you want to actually capture. I haven't seen any issues with it missing pixels or anything like that, but there could be an instance where it maybe breaks down like that, but that's just something to be aware of. Inside the event graph, only thing that we're doing here is we have this 2 execute console commands. One, R buffer visualization dump frames 1, and R buffer visualization dump frames is HDR. Basically, this is telling the high resolution screenshot command that we want to dump out the roughness, all of the layers of the G buffer, and we want to dump those out as HDR format photos. Inside of our construction script, what we're doing here is we're going to offset the camera's location by the size of the sheet. Okay, and what this is going to do is when we change our sheet size here, it's just always going to make sure that our camera has a proper distance between what we're trying to capture so that we don't miss any detail. Okay, the last thing that we need to do, and this is super, super important, is we need to come up here, and of course I've already done this, so this will be set up for you if you download the project, but if you start out a brand new project, you're going to have to do this. So you come here to go to Edit, you go to Editor Preferences, and inside of your Play, you're going to want to set your new window to something that's a power of 2. So 512 by 512 or 1024 by 1024. Okay. Once all of that is done, we go ahead and click play. I'm just going to go ahead and hit the console, the backtick key or the tilde key to open up the console. I'm going to hit up on the keyboard to populate my previous command, and I'm going to hit enter. And it's going to take a second here to render off all of that stuff. And you can see it went to Alex's desktop, and we have all of, so let me move this over and pull open Photoshop here really quick, and I'll open that as transparency, and you can see I have my base color here. I've got, oh wait, I think that might be my old one, maybe, I don't know. Nope, that's the same one. Okay. I have a base color here. I've got, let's see, I got the world normal. The world normal is one that looks a little funny, right? So like how can I get information out of this guy? What can I do to fix this? Well, there's a couple different ways to fix this. First, we can come up here to our image, and no matter what we do, we're always going to have to come up here to image. We go to mode, and then we come here to 8 bits. I'm going to click don't merge, because this is going to keep all the gamma and luminosity information the same. Then I'm going to come up here to my filters and my NVIDIA tools and my normal map filter. I'm going to go ahead and set the height field to 1.0 and the alpha. So what this is basically doing is, you see if I have this set to unchanged, or height right here. Basically, there's no information here. It's just transparent, and I don't want that. That means I'm going to have transparent background. If I set this to 1.0, it's basically going to fill in the back layer for me just with a flat normal color value. The next thing I want to do is I'm just going to go ahead and hit max RGB, and I'm going to hit OK. I'm going to do this one more time. I'm going to go filter. I'm going to go NVIDIA normal map filter. And what I'm going to do is I'm going to hit normalize and press OK. And this is just, so what I did is I took that world space normal map, I converted it, and then I renormalized it to make sure that I put everything back together between -1 and 1. Okay? So that's it. That's normal map conversion. Now, with this guy, I could hit Control-Shift-S on my keyboard. And as you can see, I can save him as a PNG or a Targa. Whatever, format you happen to use in your project. Let me go ahead and pull out another one. So let's go ahead and pull out, here we go, we'll pull out the roughness.
And another interesting note I've just found out is that a few people were asking in chat about a free version because people don't all have Photoshop. And if you're familiar with GIMP, like art tools, actually has an extension that mimics the NVIDIA clone.
NVIDIA, you could also do this in Substance Designer. You could do it in Painter. You could do it in GIMP. I don't know GIMP. I was thinking about actually trying to figure it out for this talk.
It's fun. I use it all the time.
I didn't have I didn't have time. Some other stuff came up, but. What I want to show you about the roughness here is you notice that I have it in EXR. So I had to do all that stuff for the normal map. For the roughness texture, all I literally have to do is come up here to my image, go mode, change it to 16-bit. I'm not going to merge. And now if I hit Control-Shift-S, you can see I can save it as all the other formats. Now what I can do is let me go ahead and we're going to find this guy's parent material. And actually, no, my bad. We're going to come to his material instance. We're going to disable flatten. And we'll zoom in on him. Now what I can do is if I hold down Control and Alt and I move over, and I can put this material book on there. And you can see I have the exact same material on there. What looks to be the exact same material. And the book one, this, it was one material, but the thing was I couldn't get this to capture because if I put this guy at 0, 0, and 0, he's going to capture like that, right? And I needed it to be, I need to capture the various colors, all of these colors. And there's no way using the other two methods to actually capture this stuff because they're not taking world position offset into account. And that's what's actually changing the color of this particular book. Let's see how we're doing on time here. I think we're doing okay.
Yeah, we've got, we started a little bit late, so I think we can make up the time.
Okay. I remember what the other thing I wanted to talk to you guys about was. So we've talked about there are 3 different ways to bake a material down. So there is just using the Merge Actor tool, which will allow us just very simply, without having to do anything else, merge a multiple material object into one material with one set of textures. We learned how to bake the data from a material to a render target to create a static texture out of that. Then we learned how to do something very similar to using the blueprints and the render targets, but this time we did something that took into account world position offset. Okay. The last thing I want to share with you guys is something that's in a similar vein, but not related to textures and materials at all. And what I mean by that, in a similar vein, is that it is actually a way to use a tool that already exists in a completely different way. So let's go ahead and hit Control-E on the keyboard to open up the static mesh editor of this book. And he's not as many polys as I want, so I'm going to go ahead and we're going to look at a mesh really quick. And let's see. Let's find something that's super high poly. Okay, look at this plant. This plant's pretty crazy, stupid high poly. Okay, so he's 8,200 triangles. So this is way, 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 way super high poly, especially for a mobile game, okay? Not so much for anything else, but let's say we're using this for a mobile game. So barring that it has 3 materials aside, what if we wanted to reduce just the base level geometry on this? So we wanted to take the base level of this from 8,000 triangles. Say we want to bring it down to 4,000 triangles. Now what we could do is we could take this mesh, we could come up here, we could go edit, actually, my bad. We can come here and right click on it, asset actions, export this guy out to 3D Max. Then inside 3D Max, we could run Pro Optimizer on it, or we could take it into ZBrush and decimate it, or there's a million different ways that we could take the polys out of this. But the common theme among all of these is that we have to export this out of the engine, run it through some third-party program, and then bring it back into the engine. Wouldn't it be cool if we could just optimize it right here in the engine? You can actually do that. If we come here to LOD 0, and we just come here to our build settings, oops, not our build settings, our reduction settings, I'm just going to set this down to 50 and click apply. And now you can see I am at 4,139 triangles. And you're thinking, okay, well, that's pretty cool, but, maybe I wanted to export it out. Well, the cool thing about this is that, say your art director comes by and he's like, yeah, that 50% reduction, you might want to take that back to 75. Okay, done. Now I didn't have to do anything. Look, it went up to 6,000 triangles. I literally just took something that would take me about a 5-minute round trip, and I can do it in like 10 seconds. 15%. Done.
Oh, look at that. And you can barely see the difference, too, because of the way it's triangulating. Look at that.
Yeah.
It's really nice.
And this reduction logarithm is so powerful that I do a lot of the stuff that I did for the example project that I'm working on. Once I figured out that this is such a great logarithm for doing the reduction, I just stopped exporting stuff out of Unreal and just started reducing everything inside of here. Because again, this is non-destructive. So if I go show this to Kim and he's like, dude, everything is super low poly. Everything needs to come, crank it all the way back up. I can just come in here to the meshes and crank them back up and click apply. And I've done something non-destructive, right? Yes. It's all about being able to save yourself time and energy and making sure that things are not destructive. And everything that I've shown you today is a non-destructive workflow to generate a new optimized version of an asset that you already have. And that's super, super powerful stuff.
Yeah. Yeah, overall, I think that if you apply any of these techniques as applicable, you're going to see a pretty big turnaround. I don't think that we've got just because we're working with such a small one object here, one object there. If I turn on your GPU visualizer, you're not really going to notice a difference at this rate. But a couple of people were asking about if I have a whole forest of things. I guess it's more instancing, I guess.
Well, okay, so here's the problem.
Yes.
On a phone, for example, a phone uses a tiled GPU. Yeah, we don't have the...
We need you to flip cameras real fast.
And I'm holding up my Gear VR, and it's Gear VR-iness, and there you go, haha, on a phone. On a phone, it has a tiled GPU, and with a tiled GPU, if you have a mesh object that contains a ton of vertices, or it just has this massive bounding box on it, you're going to see all these stray vertices coming at you because you've basically blown out the index. But you've blown out you have forced way too many vertices at the tiles, and they can't handle it because it's too many. So the rule of thumb is you don't want to say I had a giant square room like in the room that we're in now. I would want to use and merge stuff down that are localized clusters. So I'd want to merge the stuff in this table down, but not necessarily this stuff and all of this stuff, right? I'd want to localize this because what this allows me to do is it allows me to also make this disappear while still having these two objects here as well, right? And I can make these a cluster as well. Doing an entire forest, you are correct. You'd want to use instancing for that because an instance is basically free because you've
rendered it once.
Yeah, you've rendered it once, and then you're sharing that data. What this is doing is this is actual physical mesh data that you will be adding. So doing the forest like that, you have just turned your 200 poly bush or whatever, and you put them all together. Now you have a 50,000 poly monolithic mesh that has all your bushes, but
with culling issues are
you're going to lose culling issues. You're going to lose all LOD stuff that you can do.
Yes.
So, and if I had to do something like that, I'd use the foliage tool. This method is more. I use this when I want to bake stuff down that HLOD doesn't necessarily give me the results that I want, or I just need to, on mobile especially, having two material IDs is worse than having too many vertices. It will cause more performance issues. It's the biggest thing that you need to clamp down, and especially in VR, not so much in VR, I don't want to say especially in VR, but having as few material IDs as possible is the best way to go no matter what your platform is.
It is just general
that's
reduce draw calls as much as humanly possible. Every material that's applied to it, material element that's applied to it is another draw call. Always keep that in mind.
Yep, and you want as few draw calls as possible. So this is something that I would approach towards, we're getting ready to ship. Maybe I'm having a little bit of problems, on the Switch or the Xbox or the PS4. Like, how can I quickly and non-destructively see if this is actually giving me results? Because you can't just say, hey, I fixed something by optimizing these messages. Your technical director is going to strangle you. Right?
True. Yes.
What you need to do is you need to show them, hey, look, I did this, Control-Shift, GPU profile. I did this. Oh, this had some unintended consequences because you were working on some code. Oh, let me go backwards really quick. Undo. Instead of making this entire trip, oh, shit, I have to go. Oh, crud. I'm sorry. Oh, crud.
Gotcha.
I have to
bleep him.
I have to go back through Perforce, I have to back sync a bunch of revisions, and then I have to import this new mesh again. This just saves you having to make that entire trip through the pipeline again.
Yeah, it's definitely a pipeline reducer for sure, as well as an optimizing technique. And actually, I think it was kind of interesting. Like, normally when we talk about optimizing, it's like from the beginning we thought about optimizing. But this is, as you said, maybe you got to the end and you're here and your goal is here and you didn't quite make it. So maybe try a little bit of conversion, a little bit of tweaking.
It's always easy to tell people in the beginning you should plan and you should do this and you should do that. And while that's the best practice, it's hard to pull off sometimes in reality. And this is one of those things where if you've been doing this for a little while and you do have some proper practices and procedures in place, this can help rein in something that can become unwieldy. But again, it's just like forward rendering. It's not a magic bullet that is going to make your project run faster. It's not a magic technique that is all of a sudden going to take a poorly performing game and make it run at 90 FPS.
It's a little bit of extra performance boost here if you need it at the end. It's sort of like when we talk about crunch. Like, try to make sure you never have crunch, and everyone in the industry knows you try to never have crunch, you end up having crunch. So
it's one of those
you end
things
up
that
doing
just
like
happens.
Reducing techniques to try to actually stop it, like binary searches for the bug, et cetera, et cetera. So yeah, that's really good advice.
So that's all I have for you guys for today. Let's go ahead and jump in and see if we've got any questions or anything like that.
Yes, sir. All right, so we got a few of them coming in here. Will this work with skeletal meshes?
It will not work with skeletal. I was trying that yesterday. But I have.
But you have an idea.
I had an idea, and I tried it out, and it didn't really. I tried it on the infiltrator character, and it just didn't really come out all that well. But I tried to flatten the entire infiltrator character as a whole, and I think if I had a little bit more time, I was going to try to show it on the stream, but it started to become super complex really fast, and I didn't want to show you guys anything that just wasn't achievable, that was unrealistically, like, people at Epic tend to make these grandiose, awesome things, and it's really hard sometimes for the other people to come up and be like, oh my God, this thing is so awesome, but you feel like I can't approach this. And I wanted to try to make this as approachable as possible to everybody, because what I'm talking about and what I showed you to do today is very, very simple to do. But one thing you have to take into consideration, like the Ryan's render target tool, it looks super complex, but it started off as just solving one problem, and then he built upon it a little bit more. And that's exactly what I shared with everybody today for today's stream, is little tiny examples that you can use in your projects, and feel free to build upon this, to add more functionality to it. If you find something that you really like or really works for your project, it was kind of to give you the small building blocks to then make something awesome, because that's what everybody, I think, forgets, and that we don't tend to see, or people don't realize, is that
maybe we don't advertise it enough.
But
it's like, here's all our stuff.
We start small here at Epic, and we make these big, huge, grand things. But you guys aren't seeing that. You aren't seeing this small thing start and then grow into this big thing. You're just seeing the big thing when it's done. And this, what I shared with you today, is how a lot of this stuff starts off. And then, in a couple of months, it'll mature to something that's really big. I know that's a random tangent, but...
No, actually, I was going to say this is actually a pretty good tangent because this kind of leads into... So we've actually gotten a chance to almost document this live through streams is through talking about Bullet Train and also through Robo Recall. Here I am. Like it's all through the code too, like the old handle for it. But yeah, so you saw us when we talked about Bullet Train when it first came out, and I think I might have mentioned I walked into the room when it was Nick Donaldson in a Vive waving a box around in the air in VR, and I'm like looking on his monitor, he's like, "Is that a box?" And he's like, "It's a gun." And he's like, "Okay," and then that became Robo Recall. But there's like the magical step number 2. It's all question marks, but you don't always get to see that. But yeah, it's just iteration after iteration, and we just go, "Oh, hey, can I make this thing solve one more problem?"
Exactly.
And then you end up with these awesome suites of tools.
Exactly.
Yeah. Cool. So we've got a lot of other questions, so I'm going to try to grab as many of these as we can. Let's see here. Is the Merge Actors tool, would you call that a replacement for the Simply Gone tools, the native tool set? But we actually do have a way of reducing that, which is a totally different system.
It's the hierarchical, I cannot say that
hierarchical.
word. Hierarchical, LOD tool.
The Hyrulean.
Yeah. HLOD. That's what I like to call it. HLOD.
Yes.
HLOD is a replacement for that. This tool is similar to what Simply Gone does. The only thing that Simply Gone provided for you if you bought it was skeletal mesh reduction. So you could reduce the skeletal mesh down and its animations and everything like that, and Simply Gone would automatically handle that for you. This is a much less robust version than that, and it only handles static geometry right now. So everything I showed you right now applies to static geometry. I mean, you could, if you really wanted to, and you wanted to fly by the seat of your pants, you could take your character, you could convert the skeletal mesh inside of Unreal to a static mesh.
Yeah.
Bake it down, export that back out, and then reskin it in your modeling package.
I mean, yeah, I guess so.
I mean, that would work.
You could. Yeah,
that's why I said you want to fly by the seat of your pants.
I mean, you'd have to like put the skeleton and like completely redo.
You'd have to totally redo all your weights and all that stuff. But
yeah,
it could be a way.
And if you had a rig built around it too, then
you wouldn't have to rebuild your rig, I don't think. You would just have to re-weight and
Oh, okay.
You would just have to, basically, you'd be starting with the mesh again.
Oh, right, because the skeleton would have stayed, and then the rigs are attached to the skeleton.
Or you could have just had your character artist do it inside of Unreal in the beginning. I mean, there's this. It's called reprojection, is the name of this technique inside of 3D Max, and 3D Max and Maya and ZBrush as well, and 3D Code and a bunch of other programs. Basically, you can reproject UVs onto completely different geometry and have I could reproject a square on a cube. Okay, that probably won't work, but that's basically what you're doing. And this method is a little similar to that. So if reprojection isn't something you're familiar with, it's a super advanced technique. But it's definitely something I would have in my TA tool belt for sure.
Let's see here. Are any of these methods that we've talked about today documented in writing somewhere that people can get their hands on?
No, I have some plans to cover some of this documentation, but what I showed you guys today, if you looked at the Merge Actor documentation, I am literally using the Merge Actor exactly the way that you would use it normally according to the documentation, but instead of selecting multiple meshes, I'm just selecting one mesh.
And yet that has multiple elements.
Yeah, that has multiple elements.
All right, cool. Does the Merge Actor intend to be used with properly UV unwrapped models, or does the UV not matter at all?
So, one thing that I've noticed is if you have an object that goes out of the 0 to 1 bounds, which basically means when you look at your UV sheet, and let me show you really quick what I mean by that. If we come here to our UVs, you see this box right here, this little black box, and you can see that's our 0 to 1 range, okay? So that's what we mean when we talk about 0 to 1. So when I look inside of 3D Max or Maya, I'll also have a box like this. And that just is a way for us to know that if there's a UV down here in the lower left-hand corner, it's going to be down there in the lower left-hand corner. Now, when I say out of the 0 to 1 range, you can have UVs that come over off into here.
It'll start kicking back errors on you, though.
Yeah, it will. Let's see if... I'm not sure if any of these have them, but we're going to just take a quick look and see. No, he's pretty well laid out. The floor might have one, or the ceiling. Yeah, here we go. Okay, so you see these crazy lines that are going out here. Basically what someone did is they took probably all the polys in the ceiling right here, and they planar mapped them, and then they scaled the UVs really, really big to give a bunch of fidelity to the material that you're seeing underneath here. So basically we're increasing the size of our UVs to give us more stuff to look at. So for this particular mesh right here, what would happen is basically if I went to go run this through, it's going to cut all of this information off and put it in the 0 to 1 space. So if you have something that's super tiled, you're going to get some weird pixelation in it. So to answer his question, it is actually better to use a 0 to 1 method when you're building assets if you're going to use the Merge Actor, because you will have not better control, you'll understand what meshes will actually work better with the Merge Actor and which ones aren't. So it's going to introduce less debugging time on your part, if that makes sense.
All right. Let's see here. We have quite a few of these here. Will this be recorded at a later date? Yep, these are all going to be archived on YouTube. Let's see. Do multiple UV channels use multiple draw calls? And the draw calls are based off of the elements, not the UV channel. It's just whatever
multiple
UV is being
UV
displayed.
channels though do make your mesh heavier.
Yes.
Okay, so if you have so first off, let's just run down UVs. So UV channel 0, which will be UV channel 1 and everything else, is going to be your base color. Your normal map should be on there, and your normal map has to stay on that channel. Because Unreal is expecting the tangent information to come from that particular channel. Your second channel is always reserved for your light maps. Now, if you want to get clever with some of your material logic, you can, of course, flip these orders and do all that stuff, but that's very few part of the people. There's some ways that you can store the information differently to get different effects, but just for simplicity's sake, every time you add another UV set, so UV set 0, UV set 1, UV set 2, 3, 4, and 5, it's going to make your mesh that much more expensive to hold into memory because it's that much more data that it has to hold.
All right. Won't the UVs overlap if you merge 2 or more textures into one? And anything you should optimize for UV and 3D softwares if you later want to merge the textures in Unreal? I guess we kind of talked a little bit about how to set up the UVs in that, but
so
what prevents the UVs from creating overlapping UVs when you merge 2 different meshes together?
Okay, let me show you guys really quick. Black coffee cup was a horrible idea to add.
Yes, a black coffee cup and
let's just do a new level.
All black
quick.
Everything.
Yes.
Kind of got lost in the void there.
Okay, so let's go this guy, and we'll do no stupid coat hook.
Kind of had like a Vanta black effect where it just vanished.
Sorry, guys. Did not mean to burp into the microphone.
You wouldn't be
they
the
were
first.
tasty lies, though. All right, so let's merge these 3 guys together. So we're going to go edit. No, we're going to go window, developer tools, merge actors.
Yep.
And I'm just going to hit OK. And we're going to hit replace source actors. So what it's going to do is, so I think, yeah, there we go. Okay, so this is all one actor. So if I hit Control E on the keyboard here, now you notice I don't have any, everything still looks the way it should. This looks a little pixelated, but that's because I did a super low setting.
The self-reflection looks great.
Yeah, if I come here to my UVs, and so this is my light map right here. I don't know why it put another one right there. I think it might be a bug, I'm not sure, but this is my map right here. So this right here, that's the...
Oh, so like quartered it into chunks.
And if I had another mesh, so see I had 3 meshes, that's why I have a gap right there.
So it is almost better to do it as like even numbers or binary increments.
That was, you reminded me of one thing I wanted to show you, which was
that
a
answered a question I
drawback
didn't even know I had.
of this particular method. If we look at this map really quick here, you see I have a lot of space that ended up being wasted right here. So right here and right here. Now, you could get into the nitty gritty of this is going to, oh, that's a waste of space and there's all this and that. But what it really comes down to is if I can make this texture smaller and save myself a material call, I've made my game faster.
Yep.
Like that's literally what this comes down to. And everybody who's made a game gets to a point where the quality stops mattering, and what really matters is getting it out the door so you can feed your family. And trust me, you will get to that point.
Let's get really honest here.
That you will get to that point, and this is a great way to help you get past that line without completely destroying the quality of the artwork that you made. There's a lot of other methods that would totally destroy everything. But this method is very, very good at keeping that to a minimal.
Awesome. So we're pretty far over time, so we made up a bit of time because we were about 20 or so minutes late in the beginning due to some audio issues. But I'm just going to kind of cut it off on that one, I guess, because we have a couple. I have meetings. Everyone else probably has other things that they're going to have to get to eventually. But
sure.
I did want to say thank you so much, Sam.
Yep.
This was very enlightening.
I hope you guys learned something.
I did. I mean, I didn't know how it quartered things when it actually merges things together, so I at least learned a few things, for sure. So if you all out there also have any other questions and whatnot, please go to forums.unrealengine.com under the events section. You'll see one that's titled you'll see an event that's titled that down there, Baking Materials to Textures, and that's going to be the one for this stream. You can ask additional questions there, and we'll try to get back to you if we didn't get to your questions here. But I want to say thank you all so much for coming out and watching the stream.
Thanks for dealing with the technical problems.
Yes, and thanks for actually letting us know that there were technical problems so we could get them resolved. And we'll be seeing you all again on Thursday at 2 p.m. Eastern Time. We're going to be talking to actually a third-party software developer about ARM, which will be really cool. Check out the forums for more details. And also don't forget to like, subscribe, hit all the different buttons that are around us depending on what you're watching us on, because we stream to a few different things now. And that way you can always have the latest in Unreal Engine news. Also, follow Sam on Twitter because he needs like so many more followers. He makes so many awesome things.
Yeah, I'm bad about the Twitter.
But yep. All right. So we'll see you all next time. Bye now.
See you, everybody.